In this video at the AI Trail, we are going to discuss an update that will take your breath away. For context, ChatGPT from OpenAI, as we already know, is the top and most advanced text-based machine learning technology out there that enables users to refine and steer a conversation towards a desired length, format, style, level of detail, and language used. Stable Diffusion, on the other hand, is a latent text-to-image diffusion model capable of generating photorealistic images given any text input, cultivates autonomous freedom to produce incredible imagery, and empowers billions of people to create stunning art within seconds. Now, here's what you were waiting for. What if I could tell you that there is a new advancement made by Meta AI that most likely is going to steal the show from here onwards? Meta merges ChatGPT and Midjourney into one. Meta has launched Chameleon, a single foundation model that does both text-to-image and image-to-text generation. So what's the big deal about it? LLMs, or large language models, largely use transformer architecture, while image generation models rely on diffusion models. Chameleon is a multimodal language model based on transformer architecture, not diffusion. Thus, it is the first multimodal model trained with a recipe adapted from text-only language models. So why does this matter? This greatly expands the functionality of previous models that were either only text-to-image or only image-to-text. Moreover, Meta's new approach to image generation is more efficient and opens up possibilities for generating and manipulating multimodal content with a single model and paves the way for advanced AI applications. Let's get to the bottom of this. As we AI enthusiasts and machine learning practitioners know, interest and research in generative AI models have accelerated in recent months with advancements in natural language processing that lets machines understand and express language, as well as systems that can generate images based on text input. Last week, Meta showcased Chameleon, a single foundation model that does both text-to-image and image-to-text generation. In this video, we will get to how Chameleon AI model performs across different types of tasks, the different epic results it has produced, and go deeper into how the Meta AI team even built this in the first place. So, Chameleon is the first multimodal model trained with a recipe adapted from text-only language models, including a large-scale retrieval augmented pre-training stage and a second multitask supervised fine-tuning stage. This recipe is simple, produces a strong model, and also shows that the tokenizer-based transformers can be trained as efficiently as existing generative diffusion-based models. Wait, what in the world is tokenized-based transformer? A tokenizer-based transformer in natural language processing is a type of machine learning model that first breaks down text into smaller pieces, or tokens, using a process called tokenization. Then, it uses a transformer architecture to understand the context and meaning of these tokens in a sentence. This process essentially translates human language into a format that computers can understand, allowing them to perform tasks like text generation, translation, and sentimental analysis. Examples include models like GPT-3 and GPT-4. Chameleon achieves state-of-the-art performance for text-to-image generation, despite being trained with 5 times less compute than previous transformer-based methods. Chameleon has the versatility and effectiveness of autoregressive models, while maintaining low training costs and inference efficiency. By the way, what does CM3 in this Chameleon even mean? It is a casual masked mixed modal model because it can generate sequences of text and images conditioned on arbitrary sequences of other images and text content. This greatly expands the functionality of previous models that were either only text to image or only image to text. Although text-only generative models are commonly multitask instruction tuned on a wide range of different tasks to improve their ability to follow instruction prompts, image generation models are instead typically specialized for particular tasks. Meta applied large-scale multitask instruction tuning to Chameleon for both image and text generation, and showed that it significantly improves performance on tasks such as image caption generation, visual question answering, text-based editing, and conditional image generation. This provides another strong example of how the scaling recipes developed for text-only models generalize directly to Meta's tokenized-based image generation models like Llama. When comparing performance on the most widely used image generation benchmark, Zero-Shot MS Coco, Chameleon establishes a new state-of-the-art in text-to-image generation and outperforming Google's text-to-image model, Party. This achievement underscores the potential of retrieval augmentation and highlights the impact of scaling strategies on the performance of autoregressive models. models. Chameleon also shows an impressive ability to generate complex compositional objects, such as the potted cactus with sunglasses and hat. Chameleon performs well across a variety of vision language tasks, including visual question answering and long-form captioning. Even with the training on dataset comprised of only 3 billion text tokens, Chameleon's zero-shot performance compares favorably against larger models trained on more extensive datasets. How Chameleon performs across tasks. With Chameleon's capabilities, image generation tools can produce more coherent imagery that better follows the input prompts. For example, many image generation models struggle with the capacity to recover global shapes and local details. Chameleon performs strongly in this area. Here's a look at Chameleon's capabilities across a variety of tasks, all performed with a single model. Text-guided image generation and editing. Image generation can be challenging when it comes to complex objects, or when the prompt includes many constraints that must all be included in the output. Text-guided image editing, for example, change the color of the sky to bright blue, is challenging because it requires the model to simultaneously understand both textual instructions and visual content. Chameleon excels in all of the cases, as you can see here on your screen. First, let's look at text-to-image generation. Given prompt text with potentially high compositional structure, generate a coherent image that follows the prompt. For example, these 4 images were created for the prompts: a small cactus wearing a straw hat and neon sunglasses in the Sahara Desert, a close-up photo of a human hand model, high quality, a raccoon main character in an anime preparing for an epic battle with a samurai sword, battle stance, fantasy, illustration, a stop sign in a fantasy style with the text 1991. Next up, let's look into text-guided image editing. Given an image and a text prompt, edit the image according to the instructions in the text. Because of the generality of the Chameleon models, this was achieved with the same model as all the other tasks that we have discussed earlier. Unlike previous models such as Instruct Pix to Pix, which are tuned only for text-guided image editing. Now, let's look into text-only tasks, like understanding and generating captions about an image. The Chameleon model can also follow a range of different prompts to generate short or long captions and answer questions about an image. For example, imagine a dog carrying a stick. The prompt question will be, what is the dog carrying? Here, the model-generated answer is stick. Prompt, describe the given image in very fine detail. Model-generated answer, in this image, there is a dog holding a stick in its mouth. There is a grass on the surface. In the background of the image, there are trees. Even though Chameleon models saw significantly less data, around 3 billion tokens, compared to Flamingo, 100 billion, and OpenFlamingo, 40 billion, they match the zero-shot performance levels of OpenFlamingo on MS Coco captioning and VQA2 question answering, and even beat Flamingo by nearly 10 points on the VizWiz task. Finally, let's look at structure-guided image editing. Structure-guided image editing involves understanding and interpreting not only textual instructions, but also structural or layout information that's provided as input. This enables Chameleon models to create visually coherent and contextually appropriate edits to an image while adhering to the given structure or layout guidelines. So, given a text description of the bounding box segmentation of the image, this model can generate an image. For example, here we ask the model to generate a high-quality image of a room that has a sink and a mirror in it with a bottle at a very specific location in the image. As you can see, the results are simply mind-boggling. In another example, we gave an image containing only the segmentation with no text classes, generate an image. The input here denotes the image from which we extract the segmentation. As you can see, it detected a duck and generated similar duckies for us. Simply incredible. We can also ask Chameleon to generate super resolution images. All of the generated images shown in this video are raw outputs from the Chameleon model. However, a common trick for image generation is to add a separately trained super resolution stage to produce higher resolution images from the original model outputs. Let me show you 4 example images for each of the prompts. A steaming cup of coffee with mountains in the background, resting during a road trip. Beautiful, majestic road during sunset. Aesthetic. Small circular island in the middle of a lake. Forest surrounding the lake. High contrast. Let's look at even more prompt examples. Turtle swimming underwater. Aesthetic, fantasy. Elephant swimming underwater. Aesthetic, fantasy. Flock of sheep. Aesthetic, fantasy. Simply by understanding the given words, this next generation AI model is able to transform it into these high-resolution images that look more real than reality. So, how Meta AI team built Chameleon? Chameleon's architecture uses a decoder-only transformer akin to well-established text-based models. However, what sets Chameleon apart is the ability to input and generate both text and images. This empowers Chameleon to successfully handle the variety of tasks we mentioned before. Chameleon's training retrieval augmented following the recent work, greatly improving the efficiency and controllability of the resulting model. Meta engineers then performed instruction fine-tuning on a wide range of different image and text generation tasks. As the AI industry continues to evolve, generative models like Chameleon are becoming increasingly sophisticated. These models learn the relationship between visuals and text by training on millions of example images, but they can also reflect any biases present in the training data. While the industry is still in its early stages of understanding and addressing these challenges, Meta believes that transparency will be key to accelerating progress. As described in the research paper, we've trained Chameleon using a licensed dataset. This demonstrates that strong performance is possible with a very different data distribution from what all previous models used. By making their work transparent, Meta hopes to encourage collaboration and innovation in the field of generative AI, and can create models that are not only more accurate, but also more fair and equitable for everyone. Thank you for joining us today as we explored the incredible capabilities of Meta's Chameleon. If you found this video informative and engaging, don't forget to give it a thumbs up and subscribe to our channel for more exciting content on the latest advancements in AI. And as always, feel free to share your thoughts and questions in the comment section below. Until next time, keep embracing the possibilities of AI, and we'll see you soon.